Today's lesson is permutations and combinations. We're going to start off with an example of Ariel is trying to pick out an outfit for the first day of school. She can choose from 4 pairs of pants, 8 t-shirts, 2 sweaters or hoodies, and 2 pairs of shoes. How many different outfits does Ariel have to choose from? I love this lesson and thinking about my own closet. For this problem, we can use what's called the fundamental counting principle to find the number of ways that 2 or more events can occur in sequence. If one event can occur m ways and another event can occur in n ways, then the number of ways the event can occur in sequence is m times n. So thinking about Ariel's situation, when we use the fundamental counting principle, we can find the number of possible outfits for Ariel. Her 4 pairs of pants, I'm going to label with P there. Her 8 t-shirts, labeling with T. I'm going to label the 2 sweaters or hoodies with the H, and then 2 pairs of shoes with S there. So just taking the 4 times 8 times 2 times 2, all the different possibilities that she has for each of those, if I multiply those together, we would see that she has 128 possible outfits. Would she love all of those outfits? I don't know, but 128 are possible and completely different. Let's apply that with the example number 1 with Bruno is designing a new board game. He's trying to figure out all the possible outcomes. How many different possible outcomes are there if he spins a spinner with 3 equal sized sections labeled walk, run, or stop, flips a coin, and rolls a fair die in the shape of a pyramid that has 4 sides labeled 1 through 4? He's doing 3 things here. He's spinning the spinner, flipping a coin, and rolls the die in the shape of a pyramid. So we've got spinner, flipping the coin, and rolling the die. And I've gone ahead and put in my multiplication symbols because we're looking for all these possible outcomes. We're using that fundamental counting principle. So we're multiplying all of those together. The spinner has 3 sections there, so 3 chances on that. Our coin has 2 sides, and then the die is in the shape of a pyramid with 4 sides, labeled 1 through 4. So if I multiply those all together, we get 24 different possible combinations for his board game. Now, a permutation is an arrangement of objects in a specific order. So order matters in a permutation. I want it to be in a specific order here. So let's use the example. Flynn is organizing textbooks on his bookshelf. He has a Spanish textbook, a math textbook, and a physics textbook. How many different ways can he line the textbooks up on his shelf? So choices for his first book. He can have Spanish, math, or physics. There are 3 choices there. And let's label that Spanish, just for our notes, Spanish, math, and physics. So we have 3 choices there. Once we pick that first book, how many choices are left for our second book? There's only 2 left. So if I chose Spanish for my first book, when we go to the second book, there's only math or physics, right? And then for our final third choice for our book, there's only 1 left. So you can see that fundamental counting principle being used there. 3 times 2 times 1 equals 6. Different orders that Flynn could put these 3 textbooks. Now, a factorial, you've probably seen this and wondered about it. A factorial of a positive integer n is the product of all positive integers less than or equal to n. It is written with that awesome exclamation point, and it's read as n factorial. So this is a really neat shorthand way to do what we just did above. I could just write n factorial, and in the mathematics world, everyone understands that that means 3 times 2 times 1. You can even find this function on your calculator, and that is exactly what it's doing. So 3 factorial is equal to 6 because it is multiplying 3 times 2 times 1. All of the integers that are less than or equal to that value would get multiplied together. Let's look at our next example here. Jasmine wants to make a playlist using 5 of the 8 songs from her favorite artist's latest album. How many playlists are possible? So you have 2 choices here. You could, method 1, use the fundamental counting principle, where of the 8 songs, we're doing 1, 2, 3, 4, 5. Or think about Flynn in the textbooks. So for that first song in the playlist, there's 8 songs that Jasmine can choose from. For the second song on the playlist, now there's only 7 choices, and so on and so forth. So when you multiply those together, you get that 6,720 different combinations Jasmine can make a playlist of just 5 songs from 8 to choose from. Pretty wild, huh? Method 2, we can use the permutation formula, and this formula is on your EOC reference sheet, so I want to make sure you feel comfortable when you see it. The number of permutations of R objects taken from a set of N objects, NPR there, is equal to that N factorial over N minus R factorial, as long as the number that you're choosing from is between 0 and the number in the set. So let's look at the example for Jasmine. She is taking from the 8, her larger group. Your big selection is the first number there, P for permutations, and she's choosing 5. So the set of 8, permutation, choosing 5, and here it is filled in the formula, 8 factorial over 8 minus 5 factorial. Let's dig into this and see what's happening. So when I simplify, I have 8 factorial over 3 factorial. Let's expand it. We have 8 times 7, 6, 5, 4, 3, 2, 1 over 3 times 2 times 1. Let's simplify. Let's look at this. The 3 over 3 would cancel out. The 2 over 2 would cancel out. The 1 over 1 would cancel out because 3 times 2 times 1 is 6. And in the bottom also 6. So those are going to simplify and reduce or cancel out there. And what's left here? 8 times 7 times 6 times 5 times 4, which is exactly what we saw above. And I've got it expanded out. And again, we get the 6,720. So it doesn't matter which way you look at it. Again, the function is on the calculator. Let me show you really quick. We're going to dig into it more on the next page. But from a calculator page, under menu, probability, and there you have number 2 is permutations. It has that NPR. Your first number we want to type here is from our set of 8, comma, how many we're choosing, 5, 6,720. So different things you can use there on your calculator. So let's apply it to 2 examples here. Number 2, there are 19 students in a homeroom. How many different ways can they be chosen to be elected as president, vice president, and treasurer? So we have president, vice president, and treasurer. And the order here does matter. It's very specific. We're going to choose our president first, and then once that has been chosen, now there are less people to choose for the vice president. So from our group of 19, there's 19 people that could be voted as president. Then there's only 18 people left to choose as vice president, and then 17 chosen as treasurer. So again, you could use your calculator and just multiply this out, and it is 5,814, or you could use the formula. We are taking from our set of 19 a permutation, and we're choosing 3, and it'd be 5,814 as well. You can show that to you really quick here on the calculator menu, probability, permutation. We had 19 students in the class, and we're choosing 3 different elected positions, 5,814. Number 3, a lock has a 3-number code made up of 14 numbers. If none of the numbers are allowed to repeat, how many different numbers could you choose, the 3 different numbers, in order for a unique code? So we have like our first number, second number, third number. It says we can't repeat, so we are going to eliminate those as we go. For our first choice, we have 14 numbers to choose from, then 13, and then only 12. If you multiply those together, we get 2,184, or it would look like 14 permutation choosing 3, grabbing that calculator. So you can just straight up multiply 14, 13, and 12 together, or menu probability permutation, because the order matters. It's a code of the 14 different numbers. We're choosing 3, 2,184. All right, what about Sonic Drive-In advertising that there's more than 168,000 drink combinations? How did they come up with that number? It has to do with combinations. And in fact, if you Google search it, it kind of goes down a little bit of a rabbit hole because they include things and assume things. And so the number actually might be quite bigger, but it's a combination A combination is an arrangement of objects in no specific order. So think about it, my Sonic drink, it really doesn't matter which thing they pour in first. If they do the Coke and then the flavor, or they make the slush and the flavors and then the nerds, or it doesn't matter. It's all going to go in my cup, right? So a combination, the arrangement of objects, no specific order. So there is also a combinations formula, also on your EOC reference sheet. The number of combinations of R objects taken from a set of N objects is N. C for combinations, R, and that is our N factorial divided by R factorial times N minus R factorial. Okay? We are definitely going to utilize our calculator on this one because it's a little bit trickier to do by hand. So let's use number 4 as an example. A pizza shop has available toppings of anchovies, mushrooms, onions, olives, and peppers. I don't care which one they put on first because it's all going on my pizza. How many different ways can a pizza be made with 2 toppings? So there was 1, 2, 3, 4, 5, and we're picking 2 toppings. So this is a combination. The order doesn't matter. You need to be able to recognize the difference between a permutation and combination. So we are taking from our 5 a combination of choosing 2. Let's grab the calculator. Combinations are also there. Menu, probability, there, number 3 is combinations. We had 5 different toppings, and we are choosing a 2-topping pizza. There are 10 different combinations. So I'm just going to add here for our notes that we had 5 toppings available, and we're choosing 2. All right, number 5, a principal would like to assemble a committee of 11 students from the 18-member student council. How many different committees can be chosen? So I don't really care who I pick first. Order doesn't matter. This is different than the previous example of the president, vice president, treasurer. There were specific roles, and it mattered who I chose first because first person was going to be president. This is just a council. So we have 18 students, and we're choosing 11, right? Order doesn't matter. So this is just a combination. So we have 18 combination of 11. Let's grab the calculator. Menu probability combination there is number 3. From the group of 18, comma, we're choosing 11. Enter, wow, 31,824. That's a lot of different committees that we can choose 11 from the 18. Last part here, one of your standards talks about incorporating permutations and combinations into probability. So tying in our last lessons, let's use this example. There are 4 comedians and 5 musicians performing a variety show. The order in which the performers are chosen is random. Number 6, what is the probability that the first 3 performers are comedians? So we are finding probability of the first 3 performers. It would matter. Like the order does matter. I want the first 3 to be comedians. So order matters here, which means that it's a permutation. So recall back in probability, we did what we wanted out of our total. So we're going to look at comedians being first there out of total possibilities. So to be chosen as a comedian to be the first 3, with a permutation, we want the order to matter. So we're choosing 3 performers from the 4 comedians. So there was 4 total comedians, and we are choosing 3. We want them to be first. And then out of our total, there were 9, and we're choosing 3. So using my calculator, the 4 permutation choosing 3 is 24. And for our denominator, the total, there were 9, and we're using a permutation to choose 3 was 504. So we've got the probability of choosing a comedian, permutation, there were 3 out of 4 comedians in our numerator over our total. In our total group of 9 performers, the 4 comedians plus the 5 musicians. We're choosing 3, the first 3 we want to be comedians. And that does simplify to 1 over 21 would be our final probability there. Let's use number 7 now. What is the probability that the first 2 performers are a comedian followed by a musician? That is very specific. Order matters, right? So order matters, permutation. You might see some questions in your practice where it's a combination. The order doesn't matter. So I wish I had an extra example here on our notes. So it's not always a permutation. So be mindful of that. All right, so thinking about our probability, we want 2 comedians and 1 musician. And then we'll do over our total. Okay, I specifically wrote and here because we're going to tie in our probability lesson. Because remember, if I want this and this to happen, we multiply. Okay, so what's the chance of the 2 comedians being the first performers? So let's say there were 4 comedians, right? 4 permutation. We're choosing 2. That's for the comedian piece. And we multiply here. We want 1 musician. There were 5, and we're choosing 1. And then for our total, there was the 9, and we are choosing the first 3 performers. We want 2 to be comedians and 1 musician, so we're choosing 3 there. So we can use our calculator. We get, for the 4 permutation 2, we get 12. 5 permutation 1 is 5. Over 9 permutation, the 3 is the 504. Or let me slide down here. We have 60 over 504, which simplifies to 5 over 42. Okay. I don't teach anything I don't need to. It's in your standards to tie in your probability with these permutations, combinations. Again, you might see an example in your practice that isn't permutation. So if it's a combination, order doesn't matter. Think about your Sonic drink. Instead of permutation, we would just use combination, rely a little bit more on our calculator to compute that. Be mindful, like in number 7, we wanted this and this to happen. So we did multiply those. So a little tricky for sure. So permutations and combinations. Permutations, order matters. Combinations, think about Sonic drinks. It doesn't matter how the order that you pour my drink together. Combination, no specific order. There are formulas for that. Again, the formulas like in the boxes there on your notes are on your EOC reference sheet. So you can refer to those, but it's also a function on your calculator. So lots of information here, guys. I hope you like it, and I'll see you in class. Have a great day.